click on Solver. What is our objective? Our objective is to minimize our standard deviation by changing the weights. Don't select total weight. Subject to the constraints. Now here on the project, it'll say don't allow short selling and total weights have to equal 1. So when you're doing this, just click on the weights greater than 0. If you say OK, you're going to have to say add again. So just click add here and go to the next one. Greater than 0. Who did that? That was awesome. Not the best I've ever heard. All right, hopefully everybody's following along. I know that I probably lost you there in that formula. Total weight has to equal 1. That means the sum of them is going to add up to 1. We already put the formula is the sum of the other 5 weights. All right, now expected return. It says start at 14% on the project. So the expected return, and you could actually get a higher return than this, 14%. Now this is going to say, you can see they're all in there. This is going to give you the smallest standard deviation for a return of 14%. If this doesn't work, class is over. There we go. Solver cannot find a feasible solution. Oh. Somebody tell me what I did. I said by changing the weights below here, right? I have to change the actual weights where I named them. Solver found the solution. All right. Now, you can see that trial and error would take a very long time to come up with 6% stocks, 13% bonds, 64% small stocks, and none. Okay, you guys get the idea. Now, the reason that I've highlighted this, and this is why you want to make sure you get this right the first time, you cannot drag and drop Solver. Okay? It does not work out. So you can't just select all these and drag. I get that project turned in all the time. Sometimes it's even turned in with errors on it. Just take these, copy, come down here, say paste special, paste values. Now, if you don't do paste values, and I want to be clear about this, if you don't do paste values, you're pasting the whole formula. And so when you go back up to your working line and you redo it, each one of the ones below is going to change. So only paste the values, and that way when you go back in and you look at the formula is just the number from above. Whereas this one here is our working formula. Now, the benefit of doing it this way is go back into Solver. You don't have to change anything except for the expected return. You change this by 0.5%. The next one pops up. Paste special, paste values, back into Solver. Okay. What I'm not going to do is do all this. But you get the idea, right? Once you have it in there once, all you're doing is changing the expected return that you want. That's pretty easy, right? So it might take you half an hour to put in the formula, but it's going to take you 5 minutes to finish the rest of it. Okay. You guys get that? That's fine. People who are still awake. So that's part A and part B. Derive the efficient frontier. All I'm looking for is those graphs. You have to get all the points, graphing expected return against standard deviation. Derive the optimal risky portfolio for each efficient frontier if the risk-free rate is 3%. Superimpose the capital allocation line onto each. How do we do this? Okay. Good answers. You're like, that's why you're standing in the front. capital allocation line, the one with the highest slope. So what I'm going to do is I'm just going to use this one right here. Okay? This one's already in here using all of these. And right beside it, I'm going to come up with okay, going to do the same thing, just want to dabble working line. Working lines are nice because you can change parameters and see what happens without messing up everything else. Alright, so right here, I'm going to create a Sharpe ratio, and we know that the Sharpe ratio is the expected return minus the risk-free rate. We set it at 3%, divided by the standard deviation. We go back into Solver, and now, just once you've done all this, it's fine. Just delete all these. Or else your constraints aren't going to match up. I would figure out the other one first and then come back. Alright, so by changing the cells, and I'm just doing this as an example for the 2-asset case, you guys will understand at this point how to do it for the 5-asset case. So by changing these two cells, we want to maximize our Sharpe ratio. Subject to the constraints, we can't have either one be negative, because we don't allow short selling. We don't do anything with the return